Summary of Reaction Types worksheet. This worksheet is to be completed after you have read 11.2, which is pages 356 through 367. I'm going to show you the 5 main types of reactions with examples. The first type is synthesis. Synthesis reactions are where there are 2 or more substances producing one compound. If you look at all of the equations and the diagram in the example, you'll see that all of them have 2 reactants and a single product. Now, they're not always 2 reactants, it says 2 or more, so they could have 3 reactants, they could have 4 reactants. The main thing is in a synthesis or combination reaction, they have 1 product. The second type that you see listed is a decomposition reaction. They are basically the opposite of synthesis reactions. In a synthesis reaction, you get 1 compound as your product. In a decomposition reaction, you have 1 compound as your reactant. So in a decomposition reaction, 1 compound breaks down to produce 2 or more substances. So even if you look at their descriptions, they're basically the opposite. Now, in the decomposition reactions, you see that all of them start with a single reactant but have 2 or more products. So you can see that the products can be compounds, or if you look at the example of the mercury 2 oxide decomposing, you could then get elements also. The third type is a single replacement reaction. Now, this is the first type that you'll see that you have 2 reactants and 2 products. So in a single replacement reaction, an element and a compound produce a new compound and what we call the displaced element. Now, in the examples, we have magnesium plus zinc nitrate becomes magnesium nitrate plus zinc. The new compound is the magnesium taking the place of the zinc in the nitrate, and the displaced element is the zinc that was in the compound becomes zinc metal. The example in the diagram, you have 2 potassium plus 2 water gives 2 potassium hydroxide plus hydrogen. So the displaced element in this one is potassium is going to kick out one of the hydrogens in water. So water can be looked at as hydrogen hydroxide, HOH. So then what happens is you kick out one of the hydrogens, and hydrogen is diatomic, so the product is H2, not H. In a double replacement reaction, we have 2 compounds on both sides. So this is the first one that we have 2 compounds on either side of the reaction. And what happens is, in a double replacement reaction, the cations switch places. So the first one we have listed is sodium hydroxide plus copper 2 nitrate forms copper 2 hydroxide and sodium nitrate. So what you see is, I have it highlighted that CuOH2 is forming a solid that's called a precipitate. In the second one, we have sodium cyanide plus sulfuric acid, giving us hydrogen cyanide plus sodium sulfate. And the second one, you see hydrogen cyanide is a gas. In the third one, we have hydrochloric acid and magnesium hydroxide forming magnesium chloride and water. So those are the 3 things that happen in a double replacement reaction. The last one is combustion reactions, is when a substance will react with oxygen to form 1 or more oxides. So all of these that are listed are just simple, complete combustion reactions, where something reacts with oxygen to form carbon dioxide and water. Now that something could be a hydrocarbon in the case of CH4 or C3H6, or it could also be an alcohol in the case of C3H6O. So there are different compounds that will react with oxygen to form 1 or more oxides. Using the diagrams on the previous page, answer the following questions below. For each set of reactants listed below, identify the type of reaction that the reactants might undergo. Assume that all the reactants for the reaction are listed. So 1A, a compound and an element. That would be single replacement. Because remember, in single replacements, we have an element and a compound forming a new compound and a displaced element. 1B, 2 compounds is a double replacement reaction, In a double replacement reaction, you have two compounds that are going to switch cations to form two new compounds. C, one compound. That is decomposition, because remember in the description, decompositions have one reactant and two or more products. For each set of reaction products listed below, identify the type of reaction that might have formed the products. List as many reaction types as possible. Assume that all the products for the reaction are listed. So, 2A, a compound and an element. That would be single replacement, because remember, by definition, a single replacement is an element in a compound producing a new compound and a displaced element. 2B, two compounds. Now be careful with this one. Most likely you would say a double replacement reaction, because in double replacement reactions you have two compounds that are switching cations to form two different compounds, but you can also form two compounds in a combustion reaction, which most times is carbon dioxide plus water. 2C, one compound. That is a synthesis reaction. Just like one compound as a reactant is decomposition, one compound as a product is synthesis. 3. Classify each of the following examples according to the type of reaction involved. List as many reaction types as may apply. 3A, a match burns. That is a combustion reaction. Now, what I'm going to put in each of these is I'm going to put the balanced equation after. As you do these and it pauses, please write down the reactions so you can study them. The reaction for the combustion of a match is 5O2 plus P4S3, yielding 2P2O5 plus 3SO2. B, the carbonic acid found in soft drinks breaks down into bubbles of carbon dioxide and water. That is decomposition. There's the reaction. C, phosphorus and oxygen react rapidly, forming diphosphorus pentoxide. That is synthesis. There's the reaction. One product. D, an iron nail is placed into a copper sulfate solution. Copper metal appears on the nail. That is single replacement, because we have an element iron and a solution copper sulfate, which is a compound. Here's the reaction. E, the acid in baking powder reacts with baking soda, forming carbon dioxide gas and other products. This one is complex. It is a double replacement reaction with decomposition. There is the complex reaction. If you choose not to write this one, that's okay. F, water and sulfur trioxide react to form sulfuric acid. That is a synthesis reaction, because if you look at it, it says form sulfuric acid. That's one product. And there's the equation. G, copper wire is placed in a silver nitrate solution. The solution turns blue, which is the color of the copper ion, and a solid silver forms on the wire. That is single replacement. We have copper being the element and silver nitrate being the compound. And it says it turns blue, which is the color of the copper ion, which is copper 2 nitrate, and solid silver is forming, and that should be 2Ag solid, not 2Ag gas. This part you do not have. At this time, I'm going to ask you to both balance and classify different reactions. So you may use your notes, you may use scratch paper to balance, you may use your worksheet that we just completed. Number 1, classify. It is A. I have zinc plus copper 2 sulfate, giving me zinc sulfate plus copper. 2, classify. That is a decomposition reaction. I have one reactant. Remember, .5H2O is a hydrated compound. It is not multiplying and it is not a separate entity. 3, that would be combustion reaction. It is something reacting with oxygen to form multiple oxides, carbon dioxide and water. 4, classify. This is a double replacement reaction. I have 2 compounds on the left and 2 compounds on the right, and one of them, barium sulfate, is a precipitate. That you can tell by the S. 5, classify. That is a combination reaction. Magnesium oxide plus carbon dioxide forms magnesium carbonate. That is one product. 6, that is a single replacement reaction. On the left, we have the element calcium plus hydrochloric acid. On the right, we have calcium chloride and the displaced hydrogen from hydrochloric acid. Now, 7 and 8, we're just going to balance. The best way to do these is to write the equation, balance it, and then check the answers. B2O3 plus HF yields BF3 plus H2O. That balances B2O3 plus 6HF, yielding 2BF3 plus 3H2O. That gives me 2 borons on each side, 3 oxygens on each side, 6 hydrogens on each side, and 6 fluorines on each side. 8. UO2 plus 4HF yields UF4 plus 2H2O. That's 1 uranium on each side, 2 oxygens on each side, 4 hydrogens, and 4 fluorines on each side. Balance number 9. 2C6H6, that's benzene, plus 15O2 gives me 6H2O plus 12CO2. 2 times 6 is 12 carbons on the right. 12 times 1 is 12 carbons. 2 times 6 is 12 hydrogens on the left. 6 times 2 is 12 hydrogens on the right. 15 times 2 is 30 oxygens on the left. 6O is 6, plus 12 times 2 is 24. 24 and 6 is 30. 30 O's on each side. Number 10. C8H18O3 plus 11O2 yields 9H2O plus 8CO2. C8 is 8 C's. 8C is 8 C's on the right. 8H18 is 18 H's on the left. 9H2 is 9 times 2, 18 H's on the right. 3 O's plus 22, 11 times 2 is 25. 9 plus 8 times 2, 16 is also 25. 11, classify. That's a combination. That's another word for synthesis. 12, classify. That is a decomposition. That is one reactant, 2 or more products. 13, that is a double replacement reaction. 2 compounds on the left, 2 compounds on the right, where the cations simply switch partners.